Welcome back. We are on Class 4, Functions and Modules, and now we're going to actually jump into the heart of it with an introduction to modules and libraries in Python. Okay. Introduction to modules and libraries. We jumped over to our Jupyter Lab, Jupyter Notebook file. I've got our Day 4 IPython notebook. I also want to point out the extension IPYNB stands for IPython Notebook. So that's the extension of the file that we have here. So it's not a true traditional Python file. Traditional Python files end in a .py extension. The cool thing about the notebook is it allows us to have some metadata in there. So you'll see that I have text, and then I have other blocks of code where I can run code. So the IPython notebook is a pseudo Python notebook, or is a pseudo Python file where it allows us to run code, but it also allows us to tag in some other things like text, and like it's actually HTML. So if I double click in here, you'll see how it's actually running HTML inside the code, and then it allows me to have both code and the data around the code. But a true Python file ends in extension .py, and so if I'm creating a module in Python, I have to have a true Python file. Now in that module file, or in that Python file, I can define functions. I can define full-on classes, which we'll talk about on day 6 with object-oriented programming, and I can define variables. So let's go ahead and show you how to create a py file inside this Jupyter Lab environment, so we can actually create our own module. So I hit the little plus sign up here, and you'll see across the bottom I have different options. One of them says text file. So I'm going to create a generic text file, and I'm going to trick by renaming it to a .py extension. This is going to convert it to a Python file. Since a Python file really is just text, I can change a .txt file for a .py file. Let's give our module a name. We're just going to call this mod_test. And now we have a file called mod_test. That's Python. So we said we can define some constants. So let's go ahead and just define a constant. We'll say my age is equal to, I don't know, we'll say I'm 100 years old today. We'll define a function. Remember how we define a function with the def keyword? So we'll define display, and then in display we'll make it take no parameters. So I'll take open, close parentheses, meaning I don't want to pass anything into my function. And I'll close out the definition with our colon sign. So Python, when it runs this line of code, will go ahead and write down this definition in its list of things it knows about. And if I ever call and reference it later in my code, it knows where to look. So in our display, let's go ahead and just print, open, close parentheses, and we'll just say something like, hello world from a module, from my first module. So now I've defined a method, and I've also got a constant. If I really wanted to, I could actually define a class. We'll do that, why not? We'll call this test class. And really all I'm going to do is use our pass keyword to say, hey, I'm going to write this code later. But I just want to show you what it looks like when I load a module that has constants, functions, and classes in it. So I'm going to go ahead and hit Control S to save this file, and you'll see that that went away. So now it's saved. Now we've got to import it to be able to use it, right? So we've created this module file called mod_test. I've got to tell my application to use it. So I'm going to use an import statement. Import, you'll see, is a reserved keyword. It turned dark green and bold, which means that Python knows that word. And then I'm going to give it the name of the module, mod_test. And it's a .py file, but it's assumed, because all modules have to end in a .py, that you leave the py off, right? So I import the name of the file without the extension py. When I do that, what Python's interpreter does, it reads this line of code, and it says, okay, I'm going to open up this file, and I'm going to run this file. Oops, wrong one, this file. I'm going to put in my memory a variable called my age, make it 100. I'm going to put in my memory a function called display, and I'm going to put in my memory an object called this class. That's going to be, and it's actually a reference to it, so it's going to have the metadata behind creating a class, the metadata behind the display, and then it will store the variable. All right, so I've imported my module, and now I can reference the module through the module name. So if I do mod underscore test, and I hit a dot sign and hit the tab, or autocomplete, here it shows us the availability of things we can do. I can call a display function. I can use the constant, a statement called myAge, and then I can also reference the class called test class that's inside mod test. So we'll go ahead and use our display. We'll go ahead and hit display. Oops, not 90, shift 90. There we go. So now it's going to call that method or that function. Let's go ahead and just print something here. And this is my favorite debugging statement. I just write the word here to know that my code actually got to this point. I usually comment those out when I'm done or remove those, but this is just a good, quick, easy way to debug to let me know that my code actually gets here. And then we're going to go ahead and print out that constant, mod underscore test, and I use autocomplete by hitting tab. And I'm going to say dot tab again, and I'm going to find the myAge variable. So there we go. So when we run this, it's going to import that py file and give us access to everything inside that file. I'll go ahead and hit run, and there we go. So I got hello world from my first module. This is my local here statement, and then also mod test underscore myAge is 100 years old. Because you can start to see how we can leverage that to make code reuse, right? I can write a library to access a database, and then now I can wrap it in simple functions. Let's get users, and now in my code I write SQL underscore mod for module dot get users. Behind the scenes, the mod test.py file, or the mod SQL, whatever file you call it, will do all the hard work of actually accessing the database, authenticating, doing the query, and returning the result. And your code looks much cleaner, right? Your code just says mod SQL get users. And that allows us to abstract and remove the noisy code that does the specific logic to a easier one-stop shop py file where I can modify and change those queries for the entire program at one location. All right, so I can also stand on the shoulders of giants and reference code that somebody else has written, right? So importing modules, I can write my own modules, or I can leverage other people's modules. Python has a couple of built-in modules because they didn't want to bloat the whole language with having all these functions and stuff that you don't need on a day-to-day basis, except for certain types of programs. Math is a really good example, right? Some people do math all the time in their Python stuff. It's like data scientists and I don't know, statisticians and those types of operations. But if you're doing cybersecurity type stuff and you're querying databases, sometimes you don't need to do math. So in order to not bloat the base install of Python, they've extracted things like math or system commands or OS commands into their own modules that are still part of the core Python install, but only get pulled into your code if you import them. So let's go ahead and see what importing math looks like. So I hit the import math, and now I can type math dot and hit my tab button, and you can see all the different functions that come with math. I have all these different statements like infinity. If I want to define something that has infinite, I can define something that's not a number. That's what NaN stands for. Or pi, if I need to do some math statements that rely on the math variable pi. Instead of having to remember what the value of pi is in my head, like 3.14, I don't remember all the numbers, 3.1415692, something like that. Anyways, we could just print that out. 5265, that's what it was. Okay, yeah, but there's no way I'm going to remember that number, and nor do I need to, because math has that constant in there for me. And say I want to do the sign, so I can do math dot sign, and then I can say, what's the value of sine at, I don't know, say pi over 2. Now I got to print this whole thing out. So I got to wrap this whole thing in a print statement, right, to print that out. So we'll go ahead and print, wrap the beginning of that math statement all the way to the end of the math statement so that my print function gets the entirety of my sine functions statement. And then you can see the value is 1.0. So you remember at 0, sine should be 0, right? And then at pi, oops, not par, pi, sine is also supposed to be 0, right? It's cyclical. And we'll see that later in a graph. But you'll see that we do have rounding issues. So because pi is finite, but the sine function requires a continuous variable, you'll see that we get 1.2246 times 10 to the negative 16. It means I got to move this decimal place 16 points this way. So that number is really small, but this shows you that there is a rounding issue because we have a finite variable pi, or so we have an infinite variable pi defined in our computer with a finite resolution, right? So I don't have infinite precision. And we get some rounding issues. As long as we're aware of that, it's not the biggest big deal, right? I can also do square roots. So I can say, let's go ahead and just to get it out to the screen, we'll do our print statement. So math.sqrt, and we're going to put in here, I don't know, we'll say 25. And let me comment these out just so we kind of get rid of some of the noise. And I'll go ahead and run this, and you'll see that the square root of 25 is 5. And you'll notice that it should be an integer, but because of the square root function, it actually decides to give it to us as a floating point number. So if I did something like 24, the result is going to be 4.89. So that does give us a floating point number. So because you can get a floating point number with the square root function, it always returns a floating point number. All right, so that's the square root using the math built-in function. So what's the difference between a module and a library? Glad you asked. So a library is a collection of modules, so multiple py files, self-contained in a thing or a package, and those packages are what we call libraries. Now I can create a library around a specific theme, right? I can say, okay, and I'm going to actually use examples from 3 different libraries. NumPy is for numerical computation. So if I'm doing vector math, if actually any math under the hood probably uses the NumPy libraries. Like if I'm going to do statistics, for instance, and I'm going to do like averages, means, and all that stuff, it's going to rely on the math of NumPy. So if I pull in things like pandas, which is for data manipulation, like think of an Excel document where I can run all the different descriptive statistics, or I can run simulations and that kind of stuff. Pandas is really good at tabular data. Like think of an Excel spreadsheet for an accountant or a statistician running all these different ANOVAs or all these different math functions. Pandas is really good at that. Under the hood, Pandas uses NumPy for all the calculations. And then we'll also look at matplotlib for data visualization. How do I display values out to the screen graphically for presentations, charts, or just to understand what the data looks like? Well, we can stand on the shoulders of giants by using these libraries. How do I use those libraries? Because they're not part of the default install with Python. Well, the good news for these 3 packages, NumPy, Pandas, and Matplotlib that I'm going to talk about, we actually have them pre-installed because we used Anaconda, right? Because I downloaded Anaconda, which is meant for data scientists, these 3 packages are pretty central and core to the ecosystem for Anaconda. So it comes pre-installed. Well, let's jump over to my PyCharm. And this is an integrated development environment for writing Python packages or Python classes. And now you'll see that I have a .py file. They don't work with Jupyter Notebook files. These work with true Python files. So you'll see at the top, I'm going to import NumPy. I'm going to import pyplot from matplotlib, and I'm going to import, I don't know why I did that twice. That's kind of silly. And then I'm going to actually call some code. Don't worry about what the actual code does. It's going to plot the sine wave, because I wanted to show you the sine at 0 and how that all looks when you graph it. But if I try to run this file, because I don't have these installed in my, what is this called again, PyCharm, it's not going to let me run this code. I'm going to go ahead and run, and you'll see, hey, I'm trying to import NumPy, but it's saying I can't find that module NumPy. There's no numpy.py file that my interpreter knows about. So going back to our thing here, it says, hey, we can use the package, the Python package installer called pip, P-I-P. And we'll learn more about pip in a little bit, but let me show you how that looks when we use something like PyCharm. There's two ways I can do it. I can go to the package manager, and this goes to PyPy for me, which is the Python repository, and it shows that I have nothing installed right now. If I look up NumPy, it said, hey, I found a bunch of those repositories inside the PyPy repository online. And the one I'm looking at specifically is NumPy. And then it gives me the documentation, what website you can find more information, and kind of just scroll down, and it shows you how to import it and how to use it, and gives you a little bit of metadata about it. I can hit the install button, and it'll install it for my PyCharm. The other way I can do it is go to my terminal, and I can use my pip installer. So I can use that program that they mentioned, pip install NumPy. I go ahead and hit enter, and this is going to go to that PyPy repository, look for NumPy, and then start trying to install it. And it's a decent sized download, so it might take a minute or two. So we'll go back and talk about some other things. Oh, there it goes. It's only 15 megabytes, so it's not astronomically large, but we'll go ahead and get that one working. So the next thing is we don't have matplotlib yet either, so I need to install matplotlib. So we'll actually go to our Python package manager and look for matplotlib, and it shows up right here. And I can go ahead and hit the install button instead of doing through the terminal. So I'm going to show you both options and see how those work. Let me go back to our terminal to see how our NumPy is doing. It's updating skeleton. So hey, we've successfully installed NumPy, and it shows version 1.25.1, and it even tells us what pip version we're running. There's actually a newer version, so I could update my pip. You know what? I'll do that later. I'll do that in L. How long does it take? Copy the command. Here's my copy button, because that can go on behind the scenes. So if I paste that, just showing you how we install and update pip. Let's go to our package manager, see how PyCharm is doing. Matplotlib is doing. It shows us what's going on. So NumPy random is getting added in. Matplotlib is finishing up. So let's go back while this is going on behind the scenes. Let's go over to here and let's talk about some more stuff, right? So in Matplotlib, it's going to let us plot graph stuff. It's based on MATLAB. So MATLAB was hugely influential in my early careers because right out of college, it was one of the first programs that I started playing around with, doing a lot of simulation, developing a lot of models. So MATLAB is a great platform, and it also was one of my first programming languages because they have their own programming language associated with it. And plotting was one of the strengths that MATLAB has, and it's still a great program. You should still check it out. But it's copied their plotting libraries and made them look very similar to the MATLAB library. So Matplotlib I've used a lot because it's just the familiarity with it. I've also done a lot with NumPy and Pandas because I've actually taught an entire undergrad class on data science, or actually on statistics. So I made them all learn pandas just so that way they could try to do it manually by hand and then show how easy it is to do in a program such as Python. All right, so now that I actually have, well, let's see if I have PyCharm up and running. It's still going. Well, let's go ahead and see what happens when I try to run the code now that I've got everything installed. Will it actually run? There it goes. Shows us our plot of the sine wave. That's all I want to show you in this nice cool graph form. And you'll notice at 3.14, which is about here, we should be at the value of 0. So even though we have rounding issues, on a graph like this where you can't actually see where the value of pi is, it's to the naked eye, you can't really tell. In fact, if I can, down in the bottom right-hand corner, right here, you'll see when I'm on the graph, the value of my x, and you'll see the value of y. I can't even get, by pixels, not even allowing me to get between the two, but you see the value, how it's right around 0. Okay, so that's showing you how we can import libraries standing on the shoulders of giants that have written NumPy to do the numerical calculation. I did that in 2 lines of code, giving me those different values. And then PyPlot, which is part of Matplotlib, creating a plot in 1, 2, 3, 4, 5 lines of code, and then printing it on and showing the plot on 1. So 6 lines of code for Matplotlib and 2 lines of code from NumPy. I'm able to do quite a lot of code on the screen and do some cool graphics. So let's practice it over here. One thing I like to talk about is aliasing, and I did it, and I don't really talk about it, but I want to show you how we import something and then give it a name. Because when we did our import up here, and I imported, where's the one we made, mod test, I just did it as the name mod test, and you'll see here I reference it as mod test, but I can alias it if I don't like the name mod test. We could alias it using the as keyword. And you'll notice as also gets bolded in dark green, which means it's a reserved keyword. And then I could call it, I don't know, MT for mod test. And now instead of having to write out mod test here, I can just write MT. It's just a shorter way of being able to display stuff. And for some reason, we have the norms in PyCharm, or not PyCharm, in Python. Whenever I'm using NumPy, that I always abbreviate it as NP. So I would import NumPy as NP. And now let's just show you the kinds of the functionality that you can do. I can create an array. So np.array. And let's actually go back to our data structure. What's our most flexible data structure that we have that just allows us to have a series of things? Hopefully you said list. We're going to call it my list. And we're going to give it some values. I don't know, we'll say 1, 5, 8, 3, 9, 2. I don't know, just throwing some random numbers. So I have my list, and now let's create a new variable called my NumPy array, and we'll assign it to the np.array function and passing in my list. Great. So now if I look and I do something like my list and I do a dot and I hit the IntelliSense, here's the functionality that we get, right? I can append to it, I can clear it, all kinds of stuff. I can sort it, reverse it. What if I did the same thing with the NumPy array? So we'll hit our dot and we'll hit our IntelliSense. All right, look how much more functionality we get with NumPy arrays, right? So gives us a lot more functionality. Right, so a lot more math in there, some other things. I can take like the transpose of it. So if I'm doing matrix multiplication and I need to transpose a matrix, there's a simple, quick way to do a transpose, or I can use the transpose there. All kinds of cool stuff I can do. So it just shows you that you get a lot more functionality when you start to leverage these third-party libraries. And we'll start to see that play out in a little bit when we start to build more advanced code and start to rely on these libraries to give us quite a bit of functionality. But that's what I want you to take away from this module is first that you have to create files that have a .py extension. And I showed you a workaround method to do inside PyCharm is to create a text file and then go ahead and rename the text file to have a .py extension. So basically you're tricking the environment. And here I can't write metadata, I can't write HTML or anything like that. I can only write Python code, but at least I can still write it in my browser. Okay, so the modules have to have a py extension. To use them, I use my import keyword, and then I just give it the file name without the extension. And then that gives me direct access to everything inside that module. If I've defined classes, if I've defined functions, if I've given constants a name like a pi, or in our case we did age, right? I've made a value, or it's not a constant because I guess you can change it, but it's a variable. If we have access to those variables as well. Okay, then we talked about some of the some of the Python built-in functions, or not functions, some of the built-in modules that you can use that have functionality, like math, because we don't want to bloat the entire install of Python, we segregate out certain sections of the code, right? So math, the operating system functionality, the system parameters, so those are going to be separate imports. Right? So I could also import sys, I can import OS, and so I can get a lot more functionality by importing these as well. So play around with that. Check out what you can do with like OS, and we'll see those a little bit later. If I hit the tab button, you'll see how many different things I can do. Learn about the operating system, lots of stuff I can figure out. Environment variables and all kinds of stuff. So play around with those. Default installed by when you install Python, you get math, sys, and operating system OS. If you want to use something that's not in the default install, we have to use the Python package installer called pip, P-I-P. And it should be, if you've installed Python, part of your path variable. So I should be able to reference pip from a command line prompt as well. So if I just typed in cmd and I open up the command prompt, where did my command prompt go? There it is. And I type pip -- version, it should find the program pip and tells me which version I have. So now I'm on 23.12, showing that we were able to, oh, could not. So what was the, I tried to download it, 23.2, but I guess it somehow failed. Oh, no, it did install 23.1. So as soon as I probably reboot my computer, it'll update to 23.3.1. So right now I'm on an older version, but doesn't matter because the functionality that we needed is still there with the older version. And I showed how we could do it from a terminal to install packages, or how we can use the package manager built in with PyCharm. So play around with PyCharm as well. And last, we talked about how we can alias names. So I can use the as keyword to shorten what I'm pulling in. So I can say numpy as np, and that gives us the ability to reference it by np rather than having to do the whole module name. All right, so once we talk about that, we'll talk next about some built-in modules and look at some of the other functionality. So take a break, and I'll see you in a few minutes, and we will continue on with our discussion of built-in and external modules. See you in a few minutes.